we're going to use our knowledge of the remainder theorem that we looked at in our last video now to build up and look at what we call the factor theorem. Now, the factor theorem says if you're using the remainder theorem and you go and you try to figure out what the remainder is without actually doing division, so we're putting in x or dividing by x minus r, and if we put in that r and we get a remainder of 0, what that tells us is that that x minus r is an actual factor of that polynomial. So it's one of the things, if it said factor fully, that's one of the parts of the answer. So basically, if you're using the remainder theorem and you get a remainder equal to 0, we've found a factor. And a corollary on that, basically saying an extension of this theorem is saying if we find out that x minus r is a factor, then that value of r is actually an x-intercept on the graph. And what that means is if you go down and you're factoring something and you say, oh, one of the factors is x plus 2. What does that tell you? Well, the graph is actually doing something, crossing the x-axis, touching the x-axis at x equals -2. And that's a concept that you looked at a lot in quadratics in grade 11. So now we're going to use this. We're going to jump right in, and we're going to look at this, and we're going to say factor fully. Basically, factor this cubic function. So from grade 11, you'd had a ton, and grade 10, a ton of practice on factoring quadratics. So factoring things that were just squares. Now we're going to look at a cubic function. So we got to figure out what the factors are. Now we want to plug in some values for x and see if it equals 0 using the remainder theorem, because that would tell me what a factor is, if it would equal 0. Now we could just take shots in the dark and try, but a good place to start is think of basically all of the factors of the last, or the constant in this term. There's only two things that actually multiply to a 3, a 1 and a 3. But they could both be positive, that would get me a positive 3, or they could both be negative, that would get me a -3. And what this is saying, or where this is starting us, is saying, you know what, try these values. Try a plus, a -1, or a plus, a -3, and see what actually happens. So we're going to just start here. We're going to say step 1. Step 1 is basically find a factor. And we're going to be using the remainder theorem for that. So you go ahead and you choose one of the values from here and put it in. So we might as well just try a positive 1. So I'm going to take that function, we could call it p, I'll just call it 1, and I'm going to evaluate it at 1, at a positive 1, because that's an easy number to work with. So I'm going to put that in for all of my x's, substituting it in correctly. And they're saying, okay, if this equals 0, then I've found a factor. But basically, when you go and do all the math and crunch this number out, you get -6. So basically there is a remainder. So this means, since I put a 1 in, x minus 1 is not a factor because it did not equal 0. So that's not helping us at all. So that 1. So you try something else. So let's just try a positive 3. So we're going to put a positive 3 in. We're going to substitute it in. So 4 times 3 cubed minus 12 times 3 squared minus the positive 3 plus a 3. And that's all from what's in the box up here, that original cubic function. And when you go and crunch these numbers, you get to see that, hey, when I evaluate it at 3, this whole thing equals 0. The remainder is 0. So what does that tell me? This means x minus 3 is a factor. So that is an important thing to know. One of my factors is x minus 3. Now you could just keep going and trying to see if you could find the other factors some way. But what we want to do now is, because we already know that x minus 3 is a factor, we're going to jump in to synthetic division. We're going to say, well, if that divides out, let's divide it out of there. So we're going to actually take 4x cubed minus 12x squared minus x plus 3, and we're going to divide out that factor of x minus 3. Take it out of there and get a smaller polynomial, and then factor that. Now, synthetic division, remember, we're saying we want to make sure this original, or this big polynomial goes down in descending powers of x. So if you look, it's 3, 2, 1, and then nothing. So we don't have to add any 0 terms or anything. So we're just going to now synthetically divide that. And we remembered that We write this. In here, we put the coefficients of the term and the constant. And outside, we put the root of this. So basically, I'm putting a positive 3. We carry down the first term, and we've had some practice with synthetic division. And now we say, what is 3 times 4? Well, that's 12. And now we add these. So negative 12 plus 12, that's 0. And now we say 3 times 0, that's 0. We add these, I get a negative 1. And we go 3 times negative 1, well, that's negative 3. I add these, and I get a 0. Now remember what this meant to us when we did synthetic division. Our original dividend was cubed, so this guy starts at squared. And then I got a plus of 0x minus a 1, and this should be my remainder of 0. We already figured that out. So what this tells us is that 4x cubed minus 12x squared minus x plus 3 is the same thing as taking x minus 3 and multiplying it by 4x squared, well, the 0x doesn't make a difference, minus 1. So if we were to multiply these two factors, we're getting here. Now you have to look at this and examine, is there any more factoring you can do? Well, right here, this thing here is a quadratic, which means it could be factored. And even more importantly, you should be able to recognize that this thing is actually a difference of squares right here. So this factors to 2x minus 1, 2x plus 1. That's their factors. This factor remains, x minus 3, which means this big cubic function, 4x cubed minus 12x squared minus x plus 3, fully factored, is x minus 3 times 2x minus 1 times 2x plus 1. That's fully factored. But we could know some things about the graph from here now. We should be able to know that I have an x-intercept here at 3. I have an x-intercept here at a positive half. I have an x-intercept here at a negative half. Now the question's not asking this, but these are things we should know just from studying graphs in previous years and previous times in this course of Pre-Calculus 30. So here's the final answer, factored fully, and we can extend it a bit and figure out some roots if the question was asking that. So you factored your first cubic function. It comes down to finding that first factor, using synthetic division, and keep moving along. So we're going to do another one that's a little bigger. So this is now a quartic function. Now, I have mentioned in class a lot of times that if you could factor a cubic function, you can factor a quartic function, a quintic function, and that's what we have to do for Math 30, be able to factor up to a quintic function or a degree of 5. But you could factor something to the 20th degree if you had enough time. But we only asked you to do it up to 5. So now we're going to look at this guy, and we're going to try to determine some factors using the remainder theorem again. And you could just, as we said before, just take some stabs in the dark, or start with this constant and think, well, 1 and 18 could be some, 2 and 9, 3 and 6, all of these, and any combination of plus minuses, all of these multiply to 18. So we take a stab at it and we say, okay, step 1, let's try to find one. I don't know, I'm going to say, let's try 2. And really, I'm randomly picking something. So I'm going to evaluate this big polynomial at 2. So 2 to the power of 4 minus 3 times 2 cubed minus 7 times 2 squared plus 15 times 2 plus 18. And you're saying, if this equals 0, then I've found a factor. So I go and I try that, probably typing it in your calculator to help you out to make it a little faster, and you get 12. So this basically means x minus 2 is not a factor because I have a remainder. So we move on and we try something else. So let's try, I don't know, let's try a 3. So we put it in again. 3 to the power of 4, 3 times 3 cubed, minus 7 times 3 squared, plus 15 times 3, plus 18. And okay, let's put that in our calculator and hope it equals 0, because if it is, we found a factor. So when you try it, you'll see for sure this equals 0. And what does that mean? That means since a 3 made this 0, x minus 3 is a factor. So this is one of the final factors in this question. So like we did last time, we're going to divide it out of that original polynomial. And we're probably going to use synthetic division because it's a lot faster. So basically, showing a lot of work, but I'm going to take this quartic function and I want to divide out the factor we just found, x minus 3. So I examine this first to make sure it's in descending powers of x, which it is. Put it in here, and we put the coefficients from the terms. So a 1, a negative 3, a negative 7. Oh, I forgot an x here, right up there. 15, and a positive 18. And we're going to try to divide this out. We put a 3 out here, and that's coming from the root of this. Always carry down the first term, and we get working. So 3 times 1, that's a 3. Add these up, you get a 0. 3 times 0 is 0. Add that column, you get a negative 7. 3 times negative 7 is negative 21. You add those up, you get a negative 6. 3 times negative 6 is negative 18, which gets us a 0. And this last one's always our remainder, and we just already found out that it should get me a remainder of 0. Since this was a quartic function to start with, we now know it's 1 exponent less. So cubed, squared, just an x and a constant. So now we just look at it, and we basically determined that x to the 4th minus 3x cubed minus 7x squared plus 15x plus 18 would equal x minus 3 multiplied by x cubed. I got a 0x squared, so that doesn't count, minus 7x minus 6. So if I multiply these two factors on the right, I'm going to get this big thing on the left. But now we look at it and we're saying, okay, x minus 3 can't factor anymore, but can this thing? Well, this is a cubic function, so I have to try to factor this thing now again using remainder theorem. So I look at it and I say, okay, let's go back here and get a starting point. Either a positive or negative 1 or 6, or a positive negative 2 or 3. We try that, we use our remainder theorem, and we give it a shot. Now, just in a essence of speeding this up a bit, we're going to, with this, say, you know what, f at negative 1. Let's try that. So then I have a negative 1 cubed, and this is all coming from this polynomial. So a negative 1 cubed times negative 7 times negative 1 minus 6. And if you put that in your calculator, you'll realize that if I evaluate this polynomial at negative 1, I get a 0, which is telling me that because negative 1 worked, x plus 1 is a factor. So now I've found two factors to this quartic function at the beginning. One was x minus 3, now one is x plus 1. So now we have to take this cubic function here, x cubed minus 7x minus 6, and we need to divide out the factor we just found. And again, we're going to use synthetic division. So we put it here, we examine this and say, oh, is this in descending powers of x? Well, it goes from a cubic to just an x, so we got to add a 0x squared in there. So it's going to be a 1, 0x squared, a minus 7, and a minus 6. And we're going to take the root out front of negative 1, and again, that comes from this part. Always bring down the first term, start multiplying and adding. Negative 1 times 1, negative 1. Add that up, I get a negative 1. Negative 1 times negative 1, well, that's positive 1. Add that up, I get a negative 6. Negative 1 times negative 6 is a positive 6. Add it up, I get a 0. In synthetic division, this is always the remainder. We were dividing a cubic function to start with, which means this is going to be squared, an x, and now a constant. So what we just found out is that we have this big thing now can be broken up. This x to the fourth minus 3x cubed minus 7x squared plus 15x plus 18 has factors. One of them was x minus 3 from the first time we did the remainder theorem. One of them was x plus 1. And now we've got this quadratic function, which is x squared minus x minus 6. And we're saying, oh, we're almost there. It's a long process. And that's what I'm saying you could do if you had the time. You could do 1 to a power of 20. It would just take a long, long time. So now we examine this last thing and say, can it be factored? Well, this is a quadratic from grade 10. And we got to look at it and say, basically, what are two numbers that multiply to negative 6? I'd add to a negative 1. To factor that, that is x minus 3 and x plus 2. That's the factors of this. That's grade 10. We have x plus 1. We have x minus 3. And now if we examine this, x to the fourth minus 3x cubed minus 7x squared plus 15x plus 18. This very large quartic function, fully factored, breaks down to these 4 factors. But means if I was to FOIL or multiply all 4 of these factors, we'd get that quartic function. So that's the final answer. But just to take it a step further and deepen our understanding, that means this graph has an x-intercept at 3, at negative 1, another one at 3, so there's a multiplicity happening there, and then at negative 2. So we can see that this is fully factored. It gives us a little bit more information. And this probably could be cleaned up a bit, these factors on the right-hand side. Since there's 2x minus 3 factors, more likely you're going to see x minus 3 all squared, x plus 1, x plus 2, equaling this big quartic function that we started with. So we factored a quartic function, and you could see it's not any harder, it's just a lot longer because you have to keep using either the remainder theorem and the factor theorem if you have a cubic or quartic function, and you just keep going down. So I'll do some more supplementary examples in another video if you need to take a look, but for right now, this is how we can use the remainder theorem combined with the factor theorem and synthetic division to factor cubic, quartic, and quintic functions.